this, okay? The genetic material in the nucleus of a band is shaped like a band, like a banana shape, all right? So if I were to look at a neutrophil, and I were to look at the nucleus right here, that's the nucleus right there, okay? That's the genetic material in the nucleus of a banded seg, of a banded neutrophil, right? My segmented neutrophil right here looks like it's got, oh, dad, let me draw the nucleus right here. This is my nucleus right here, this is my nucleus right here, my nucleus right here, right here. This right here is the genetic material, the DNA, in a segmented neutrophil. And it's segmented because it looks like it's got more than one nucleus. It is a segmented nucleus, all right? It's also called a PMN, polymorphonuclear. PMN, polymorphonuclear, because it looks like there's more than one nucleus, but there isn't. With better electroscopy, better microscopy right there, it was found that all these nucleuses are linked. So there's only one nucleus, It's not polymorphonuclear like we thought it was for a long time. So the difference is right here, this is young, this is old. There's a shift from young to old in the generation of the life of a neutrophil. And what this is good for, what it tells you, is that this sucker is activated. If you have a bacterial infection, it takes about a week for these things to respond to it. You want a shift. You want more segmented neutrophils than banded neutrophils, because that means that there's a proper response to a bacterial infection. Don't need that in your answer. I want you to know what bands are and what segs are, okay? Now, okay, a few more minutes right here and then we'll call it quits for right now, and I'll come back a little bit later on. Prostaglandins and leukotrienes are released from the neutrophils, all right? Now, prostaglandins are for pain sensation. We know that. But there's another benefit of prostaglandin is vasodilation. You dilate the blood vessels in the local area. You dilate the blood vessels in the local area, in the local infected area, where you have an increase in neutrophils right here. And leukotrienes are chemoattractants. Leukotrienes are chemicals released from neutrophils that attract other white blood cells, right, to the area. They attract other neutrophils for one thing. So leukotrienes have a benefit, prostaglandins have a benefit besides the pain sensation. They are vasodilators. Okay. Now we have suffixes, words at the end of a basic word right there, that tells us the numbers. Penia, cytosis, and philia. Well, cytosis and philia mean an increase. A leukocytosis is a general increase in white blood cells. A leukophilia is a general increase in the production of white blood cells. Doesn't tell us specifically which one it is, but more than likely it's going to be a neutrophil, or it could be an eosinophil. An eosinophilia is an increase, all right? Eosinocytosis, a tougher word to say, we don't use it that much. Eosinophilia is an increase right here. Now, we have a penia being a decrease. A neutropenia is a decrease in the number of neutrophils right there. An eosinopenia is a decrease, okay? Etc. Could use any of these other leukocytes, but I didn't, all right? Now, the unevenness of the blood cell production, I'm going to quit on this in here, but I'm going to do this one first, all right? We have in here on figure 1911, that's what I want you to take a look at, figure 1911, my page 659, your page, probably page 680 or something like that, okay? The unevenness of blood cell production. Now, what I want to talk to you about is colony-stimulating factors. So let me draw that up here. We'll focus on this for a few minutes and I'll quit. All right, here's the bone marrow. The major stem cell in the bone marrow where all blood cells come from. Remember the name of it? We mentioned it the other day. Yesterday, okay? Hematocytoblast. Or hemocytoblast. Either word is fine. Hematocytoblast is what I learned. Now, from this one parent cell, we get all the other blood cells, okay? We get the reds or whites. We haven't even mentioned the word platelet, okay, a thrombocyte. We haven't even mentioned that one at all. But anyway, we don't really call that a cell, it's a cellular fragment. So it's not really a white blood cell as such, so I don't have it listed up there. So here we have a colony of reds. Here we have a colony of whites. Right? And all of these come from a single parent cell. Now there's several different types of stem cells in the line of a particular red blood cell, for instance, and I asked you to learn some of those, no big deal on that. So, but I don't really care about the normal blast, but somewhere down in here in this red cell line, and this red cell line right here, this red cell is turned on, turned on, turned on, turned on, and here we have a mature red blood cell and a erythrocyte. All right? Now this is a colony. Each line represents a colony. So what is the colony stimulating factor for the erythrocytes? And you know this. What regulates the production of red blood cells? You know this, all right? So think about it for a few seconds. What stimulates the production of red blood cells? Oh, that's EPO. So EPO is the colony stimulating factor for the red blood cell. And I'm going to put down EPO up here. This is the only one that we do know. EPO right here stimulates this production of this colony of red blood cells. Now, before I continue right here, I'm going to put lymphoid cells on this other side over here, myeloid cells on to the left of it. So there's two categories of productions of the leukocytes here. A lymphoid cell line and a myeloid cell line. Lymphoid would be the last one over here. Lymphoid. The lymphocytes, okay, about the second most common white blood cell that we have right here. So this is the lymphoid cell line. This is the lymphoid cell line. These others right here are the myeloid. M-Y-L-O-I-D. M-Y-L. The myeloid stem line, okay? So, M-I-E, beg your pardon, M-I-E-L-O-I-D. So these would be our eosinophils, our basophils, our neutrophils, okay? Monocytes, those are the myeloid cell line. Now, with that in mind, what stimulates the production of the lymphoid cells? Well, it's going to be the lymphoid colony stimulating factor. It's that simple. It's that complicated too, because we don't know what that it is. We know the EPO turns on the production of the red cells. The lymphoid cell line, the production of the lymphocytes turned on by the lymphoid colony stimulating factor. All right. Let's say that we have right here basophils. Look at this line right here, basophils. Lymphoid, basophil right here. What turns on the production of basophils? Well, it's the basophil colony stimulating factor. It is that simple, but we don't know what that it is. So that makes it more complicated, right? So there's a colony stimulating factor that turns on the production of all these various types of cells. Now, it is an uneven production. It is an uneven activation, because we know that the erythrocytes right here, the red blood cells are turned on, they're wide open all the time. 1 million every 1.3 seconds. We don't have that in the white blood cell line, okay? So there's an unevenness in the production of all our blood cells right here. With that, the red cells being the most, the neutrophils being second, lymphocytes being third, and the rest of the other three being about equal. What stimulates their production? A colony stimulating factor. Okay? So I'm going to quit for right now. I'll pick it back up here shortly. All righty?